So we'll get into calculations with the activation energy, but first let's look at just drawing out one of these reaction diagrams and thinking through this transition state. So this was kind of the example collision theory problem we were looking at, or reaction, where we have hydroxide combining with CH3Br and forming methanol and bromine ions. So if I wanted to draw an activation, or sorry, if I wanted to draw an energy diagram for this, I would have my energy axis. Um, and this hasn't, well, let's just assume this is exothermic. I can show you what it looked like endothermic. So I'll start with my reactants at some sort of energy level, and then I'll always have an increase to an activation energy, and then for my products. The energy, if I know the activation energy, I can plot this relative to my energy scale. Otherwise, I'm just going to estimate it, and just it'll always be higher than your reactants, right? And so we're just trying to show a relative increase. And so I've got my hydroxide ions for my reactants and my CH3Br coming together. And I have my methanol and my bromine ion as my products. And my enthalpy would be right here, and my activation energy would be represented here. If this was an endothermic reaction, the shape of my diagram would look like this, and I would have a positive enthalpy and an activation energy that overlapped it like this. And so what about this activated complex, this transition state right here? I'll draw that over here. So as this hydroxide approaches, we know that it's coming into this carbon right here. So our activated complex, or our transition state, is going to look like something that has half formed that bond and half broken the bond to our bromine. So we know this one right here is going to break. So the kind of central piece of this is this carbon breaking its bond to its bromine, and that bond lengthening as it starts to form this bond to this oxygen, which is bonded to a hydrogen. Throw some electrons in for fun. And the hydrogens bonded to the carbon aren't really doing anything other than kind of getting out of the way, possibly, and they're wiggling around. So I'm just going to put these here in the middle, and I'll keep them. So I realize my dash lines for geometry and for my partially broken look kind of the same. So let's kind of clear that up. There we go. That looks different now. And so the pieces that are changing is we have this bond right here forming, and we have the bond between carbon and bromine breaking. And so this is what my transition state would look like. And we typically put brackets around this like this. We put a little to show that's a transition state, kind of a formality.